Chapter 9 is about electrons in atoms and the periodic table. You guys heard about the Hindenburg? This happened a long time ago, 1937. They had made this dirigible, a blimp, and it was filled with hydrogen. Hydrogen's really flammable. And when they were landing, it burst into flames, and 36 people died. It was a big tragedy. So why talk about this in chemistry? The question is, what makes hydrogen reactive? Why does hydrogen burn? Helium doesn't burn. Helium is the next element. It's, very similar in size to hydrogen, and yet it doesn't react. Why? So hopefully we're going to answer some questions in this chapter and help to understand why the elements behave like they do. So the modern blimps that you may see, over a big sporting event are filled with helium. But helium doesn't burn. Okay, kind of got ahead of myself. Really got ahead of myself. Yeah, so here are some of these questions written out. Why are helium atoms inert? What makes them that way? Why is hydrogen so reactive? Hydrogen as an element is diatomic. You guys need to know that. It's one of those 7 that forms molecules of 2 atoms. Why does hydrogen do that? Helium doesn't do that. Some of the elements do, some of them don't. Oh, these slides have so many words on them, don't they? What we'll find is something related to Mendeleev's periodic law, that there are patterns of behavior in the periodic table. We'll find out that the periodic table is not just some random arrangement of elements, but there's actually some really important patterns in there. And we'll talk about some models and theories that help us to understand the behavior of some of the elements. So we're going to have to look at individual atoms and what they're composed of. And 2 models for the atom are the Bohr model and the quantum mechanical model. One of them, the Bohr model, was developed first. It's very simple. And it does give us some insight, and that's why we still teach it, although we understand now that it's not correct. But we can still learn things from things that are not correct. The quantum mechanical model is the model that's currently believed to be correct, and we're going to kind of scratch the surface on that one, because if you get deep into it, it's pretty crazy. And there's a lot of really high math in there, and we don't want to go there. But we'll talk about it just enough to understand a little bit. Behavior of atoms has a lot to do with the electrons. The electrons are going to affect the chemical and physical properties of the elements, and we'll hopefully see that as we go along. Here's some pictures. I'm not going to test you on these guys' names. This is Niels Bohr and Erwin Schrödinger, and these guys had some very, very important ideas. What's interesting, Schrödinger and Einstein both contributed to the quantum mechanical model of the element. And so they're making observations, they're devising hypotheses, and they're testing them, and they're coming up with theories. They came up with this idea of quantum mechanics. And yet they were bewildered by their own theory. They're like, this is the only thing that seems to explain the behavior, and yet we don't understand this. This is weird. So it's kind of interesting. We could do, many classes on the history of chemistry, but we're not going to do that.